Today, I'm going to talk about the software side of this DIY attitude indicator project. If you're like me, zero programming background, but still really want to mess around with small tech projects, then this video isn't about teaching you code line by line. Instead, it's about giving you a way of thinking, how to go from I have an idea to this thing actually works. And if you don't feel like listening to me talk, no problem. I've put the code in the link below. You can just download it and play with it yourself. First, why an attitude indicator? Honestly, mostly because it's fun. Riding a motorcycle is sometimes called flying close to the ground. Even though I'm a pretty conservative rider, leaning into corners is unavoidable. And every now and then I get curious, how much am I actually leaning? Because what it feels like and what it looks like to others can be very different. The second reason is soul. If you've ridden here or seen my previous riding videos, you know the roads go up and down constantly. They're rarely flat. Sometimes while riding, I'd feel like the bike wasn't accelerating properly. So I started wondering, is this just because I'm going uphill, or is there actually something wrong with the bike? But again, if I'm being honest, this project is still mostly about having fun. Even though it was just for fun, I had never touched an ESP32 board before this. I assumed building an electronic attitude indicator would be complicated. That changed when I saw someone else's video. I realized, wait, this actually doesn't look that hard. And since a development board can be used for all kinds of creative projects, I figured, why not try? So I bought some parts, and that's how this attitude indicator was born. All right, that's enough backstory. Before we get into the main content, don't forget to like, subscribe, and hit the bell. Okay, now let's actually start. What you need. Here's the full list. A brain with ideas, a computer, a USB-C data cable, M5Dial or any ESP32-based board, GY87, MPU 6050 or any module that includes an MPU 6050, jumper wires, a soldering iron, 2 AIs, and Arduino IDE. Let me explain a few of these. Why M5Dial? Honestly, no deep reason. It just looks good. And from real-world use, it's actually very convenient to work with. GY87, the important part here is the MPU 6050 itself. It includes both a gyroscope and an accelerometer. Compared to using only an accelerometer, this combination handles both straight-line acceleration and cornering much better. In short, more stable, more reliable data. The 2 AIs, GPT and Gemini. Throughout this project, I used both GPT and Gemini. If I imagine them as two people, both are excellent programmers. But GPT feels less familiar with ESP32 development. It's like asking a Python expert to help you, technically correct code, but the overall structure isn't always ideal for ESP32. Gemini, on the other hand, seems much more comfortable with ESP32 boards. It usually gives better overall logic and can produce a complete working program faster. That said, Gemini isn't perfect. Sometimes I ran into small issues that Gemini just couldn't solve, no matter how many times I asked. When that happened, I'd ask GPT, and GPT often fixed those specific problems right away. So my personal recommendation, use Gemini to build the main structure. If you get stuck on a small issue, ask GPT for help. About zero programming experience. I say I'm a beginner, but realistically, I'm probably a 0.5, not a true zero. I've had some programming experience before, just not with ESP32. To be honest, even now I'm not 100% sure what language this code is written in. And that's completely fine. If your goal is to learn programming from scratch, this video probably isn't ideal. But if your goal is to learn how to turn an idea into a working app or device, then this should still be useful. Getting started in Arduino IDE. First, connect your hardware to the computer and open Arduino IDE. Take a quick look around the interface. Don't panic just because you see code. For anything that's not extremely complex, AI can handle most of it. If you're unsure whether your idea is too complicated, ask AI first. For example, if you want your M5Dial to time travel, AI will probably tell you it's impossible. And in that case, yeah, it probably is. At its core, Arduino IDE is mainly about writing code and uploading it. You can't preview the program on your computer, but upload times are short, so just wait a few seconds. Installing board support. Before writing code, you need to install some libraries. First, open Board Manager, search for M5, install M5 Stack. Then, Go to Tools, Board, select M5 Stack, choose M5Dial. Now open your computer's device manager. Make sure your M5Dial is connected via USB. You'll see a USB serial device. Note the COM port number. Back in Arduino IDE, go to Tools, Port, select that COM port. You don't need to fully understand this. All it does is tell Arduino IDE which device to send the code to. Installing libraries. Next, open Library Manager. Search for M5 and install everything related. Then search for MPU6050 and install that as well. These libraries save you a ton of work. They're basically pre-written code that you can reuse instead of starting from zero. Even if you don't understand what calling a library means, that's okay. A quick tip about sensors. If you want to build something else in the future using different sensors, always ask AI first. Does Arduino IDE have a library for this sensor? If a sensor has an existing library, use it. Writing signal reading code from scratch is much easier to mess up. A human-written library is usually more reliable than AI making things up on the spot. Soldering the sensor. Now we do a bit of hands-on work. If your project doesn't use sensors, you can skip this part. M5 Stack has dedicated data cables that plug into port A or B. Both work the same. Each port has 4 wires, clearly color-coded. The sensor pins are also labeled, so it's basically just matching them. For safety, if your data cable is already connected to the M5Dial, unplug the USB-C cable before soldering. Soldering tips. Apply some flux to the sensor board first, then add solder. It'll stick easily. Tin the wire with flux and a bit of solder. Place the wire on the correct pad. Touch briefly with the soldering iron. You don't need to hold it for long. If you're using the GY87 MPU6050, once everything is soldered and you plug in USB-C, the LED on the sensor should light up. That only means power is working. We'll test the data connections later. First, code upload. Now open Google Gemini. The first step is simple. Just test the full workflow. Write code, upload, see something on the M5Dial. If you tell AI that you're a complete beginner, it'll guide you step by step. That's exactly how it guided me. Originally, I wanted to adapt someone else's code, but their project used a square screen and mine is round. The sensor was different too. Copy pasting wasn't going to work. In the end, AI just generated everything from scratch, so I didn't even need to reference other people's code. That said, when I first talked about porting existing code, AI still gave me a very solid starting approach, and that helped a lot. For this part, all you need to do is copy the code, then go into Arduino IDE, select everything in the code editor, and paste it in to replace the existing code. After that, just click Upload. At first, I used to click Verify first, but later I realized that when you click Upload, Arduino IDE runs the verification automatically anyway. So once the code is pasted, you can upload it directly. After the upload finished, my M5Dial didn't react at all. It turned out I just needed to press the reset button once and everything worked normally. On the back of the M5Dial, there are only 2 buttons. One is the G0 button in the center of the sticker. The other is the reset button. If you get an error when uploading, try this. 1. Unplug the USB-C cable. 2. Hold down the G0 button on the back. 3. Plug the USB-C cable back in. 4. Try uploading again, or simply press reset and see if that helps. One more thing worth mentioning. When you see the message hard resetting via RTS pin in the status area at the bottom of Arduino IDE, that actually means the upload is complete. The first time I saw that message, I just sat there waiting, thinking something was still happening. Later, I asked the AI and realized it was already done. Of course, in every conversation about the code, the AI will also give you very detailed explanations. Why the code is written this way, why something needs to be changed, what the change actually does, and so on. If you're modifying existing code, it will explain why the old version had issues, why this new approach works, and what effect the change has. And if you run into an error, you can simply copy and paste the error message into the chat. The AI won't just give you a fix. It'll also explain what the error means, why the previous code caused it, and what's going on behind the scenes. In other words, the conversation is never just about code. Of course, if you don't care about the explanations, you can just ignore them. One more important thing to mention. Once you have an idea, you should also think about possible problems in the real-world use case, and then ask the AI whether those problems can be solved through code. For example, I asked something like this. Since I'm planning to mount this on the motorcycle handlebar as an attitude indicator, ignoring visual details for now, will the current setup be able to prevent acceleration or deceleration from affecting the readings? And the AI was able to give me a clear answer. Of course, during the conversation, anything you don't understand, you can just ask directly. For example, you might ask something like, why does a gyroscope drift over time? Why does the angle slowly change by itself when the device is left sitting still for a long time? That kind of question is completely fine, and the AI will explain it to you. After that, it's really just a loop. You keep describing your specific requirements, the AI gives you code, you check what still needs improvement, then you ask again, and it responds with updates. Along the way, you'll probably run into compilation errors or unexpected behavior. When that happens, you just copy and paste the error message, and the AI will help you fix it. It's basically an iterative cycle, gradually turning your ideas into features, one by one, until your app does what you want it to do. As I mentioned earlier, Gemini can still struggle with some small issues. For example, early on, the Triumph logo in the center of my attitude indicator kept flickering. The app was usable, but that constant flicker was really annoying. I tried fixing it by talking to Gemini and tweaking the code several times, but nothing worked. So I decided to ask GPT instead, and GPT's solution finally fixed the flickering problem. If you work with Gemini from the beginning, the code naturally builds up inside the same chat. So when you add new features or run into problems, you don't need to paste the full code again. However, if you switch to GPT in the middle, then besides explaining your request, it's usually necessary to paste the entire code. That way, GPT can modify things based on your current version. The advantage of doing this is that the code you get back is usually ready to run with a simple copy and paste. After GPT modifies the code, when you go back to Gemini to continue adding features, remember to paste the full updated code there as well. Take the flickering issue as an example. GPT fixed it by changing the display logic. Even though only part of the code was modified, you still want Gemini to continue working on top of that new logic. Otherwise, Gemini might unknowingly make changes that conflict with GPT's fix. About the visuals. There are two main approaches here. The simpler one is to draw everything purely with code. You describe the visual layout as clearly as possible. The AI generates the code, and then you fine-tune it from there. The second approach, like the Triumph logo in the center of my attitude indicator, is to use image assets. But using images in Arduino IDE is actually quite a hassle. You can't just import an image file directly. The image has to be converted into code, which takes up a lot of space. For example, I only used a single 240x240 image for the center logo, and once converted, it became over 3,000 lines of code. If you really want to use images, you might want to try other tools. Squareline Studio, for example, supports ESP32 development and makes this process much easier. One more thing to keep in mind. The M5Dial system does not support transparency, so if you want the round display to look more three-dimensional, like a sphere, you might think of adding a soft gradient shadow around the edges, like you would in Photoshop. That kind of effect isn't directly supported on the M5Dial. It can be done purely through code, but it's more complicated. Since this is a relatively simple project, if you spend 2 or 3 hours chatting with the AI, that's usually enough to build a pretty decent little app. So that's the full process of using AI to build the software side of an electronic attitude indicator on an ESP32 board, specifically the M5Dial. Let's take a look at version 1.1. Visually, it looks almost the same as the version you've already seen, but there are a few important changes under the hood. First, I fixed the issue where the roll and pitch directions were reversed. Second, I added a one-button recenter reset function. And finally, there's now a long press power off feature. Hopefully this gives you some ideas and maybe even helps you get started on your own project.